Simulating our world deals with computational abstractions, a term that's probably caused more confusion in the national curriculum than any other. Yet it shouldn't, because modelling has been on the curriculum even since the early days of the national curriculum. One of the problems with modelling, though, is that the predominant suggestions in the past have been analytical models. These are often represented as spreadsheets where you embed the rules of the model in the spreadsheet, and they're deterministic. Whenever you put the same data in, you will get the same result out. The problem with deterministic and analytical models is that anything beyond something quite trivial requires a mathematical grasp far beyond that of the average Key Stage 3 child. So this session suggests a different approach. It looks at agent-based modelling. Dynamic, decentralised systems. Dynamic in the sense that the outcome can't be predicted in advance. Decentralised in that the group behaviour that emerges is the result of simple behaviours of individual agents. And it occurs in many different forms in the natural world. Think, for example, of the flocking behaviour of birds. On the surface, children might think that one bird is the leader. And yet, this group behaviour emerges from individual agents following very, very simple rules. Because the rules are simple, it means that children can program these, provided we have some programming environment that allows them to do this. Most children are familiar with block-based languages, and Mitch Resnick, the key player in the development of Scratch, also developed a dedicated modelling environment known as StarLogo. So we use StarLogo to explore a variety of models, challenging children to think about the rules underlying those. There are 5 sessions in the unit. The first, analytical models, explores some environments for looking at deterministic models and some of their limitations. The second, decentralised systems, introduces some of the fundamental concepts for understanding decentralised systems and agent-based modelling. The third, emergent behaviour, takes the rules behind developing termite mounds as the starting point for an investigation. Complex investigations, the fourth of the sessions, takes these ideas further and looks at ways in which we can analyse the behaviour that emerges from the models. And finally, building models allows the attendees to develop their own models. We hope above all to convey several key points. Firstly, that dynamic decentralised systems are everywhere. They're a hugely motivational context within which to explore computation, and they're easy to program. Above all else, they're a good vehicle for developing the concepts of computational thinking that we've tried to encourage throughout all the Tenderfoot sessions. So this is not a unit that is focused entirely on learning a language or learning an environment, but it is using the context of a decentralised system to pose challenging questions and through that develop the computational thinking to allow children to explore solutions.
For more information about CAS Tenderfoot resources to support training for Key Stage 3 computing teachers, go to www.computingatschool.org.uk/Tenderfoot.